Hi, welcome to Advanced Mathematics. Chapter 11, Trigonometric Identities and Formulas, Part E, page 2, on half-angle formulas. As usual, see if you can work through this on your own using the answer key as a reference. And if you've got questions or need a little extra sort of input on this, then go ahead and watch this video and learn a little bit more about it. So this page, the last page of the unit, we've talked about double angle formulas already, and we're summarizing them here for you. So this is just a repeat of what we did on the previous page. Now, you can play an interesting trick here. If you, on the right-hand side of these equations, if instead of a you wrote a over 2, then these formulas could be rewritten with the a over 2 on this side, and then this side would be 2 times a over 2, which would just be a. So you have a over 2 is over here, and a is over here. And in that situation, you can solve for the, in this, well, you use this one in this case would be, you'd be solving for the cosine of a over 2. In this case, you could solve for the sine of a over 2. And you could solve here for the tangent of a over 2. And the solutions for that are a little involved, and you just don't need to know what they are, because it's been done, and we just really want to talk about what the result is. So this is what you get if you solve for sine of a over 2. You get this nice expression over here with plus or minus in front. Same cosine, it's kind of similar. And then the tangent of a over 2, you get this. Now, in these two, the cosine of a over 2 and the sine of a over 2, the plus or minus is a little bit of a tricky thing that I need to talk about. So when you use the half-angle formula, you need to be aware of what quadrant angle a over 2 lies in. So you need to be aware of what sign, S-I-G-N, your answer should be. So for example, if you do the half-angle formula for sine of a over 2, you need to think about what that angle a over 2 is going to be in terms of its quadrant, so that you know whether your answer should be a plus answer or a minus answer. So you have to use some intelligence to think about whether your answer should be plus or minus. Same thing here. All right, now we have some examples that we're going to try. We're just really plugging in to the formula above. And these come in handy, frankly, when you're working with angles that are friendlier to the unit circle. So, for example, doing sine of 15 degrees. Now, 15 degrees is not one of the angles that we have on a unit circle. So that's a problem. But we can use the sine of 15 degrees and the half-angle formula to come up with an exact expression for it, which is pretty cool. So, if the sine of 15 degrees is really the same as sine of 30 degrees over 2, we can use the half-angle formula, and we'll get something that's in terms of 30 degrees. That's nice because 30 degrees is an angle on our unit circle. So let's see how that works. So using the half-angle formula for sine of a over 2, we're going to be using plus or minus the square root. Well, that was a mess. The square root of 1 minus cosine of, now the formula says cosine of a. Now in this case, a is 30 degrees. So it's going to be cosine of 30 degrees. Not 15, it's 30. You see why this is nice? Okay. So, well, that's pretty cool. Cosine 30 degrees is root 3 over 2. Now, before I go any further, I want to address the plus or minus here. So 15 degrees puts us in the first quadrant. So I know the sign of something in the first quadrant has got to be a positive number. So that means this plus or minus, I can just go ahead and say it's a plus. Okay, so this is equal to just the square root of 1 minus root 3 over 2 all over 2. So what can we do about that? We want to simplify that a little bit. So we have the square root of, I'm going to take this over 2, and I'm going to bring it sort of outside and say I'm going to take the numerator and multiply it by 1/2. So I'm really saying 1/2 times 1 minus root 3 over 2. And let's see if I can get a little more space over here. Ooh, I can. Look at that. And so let me distribute the 1/2. It's going to be the square root of 1/2 minus root 3 over 4. Equals, I'm going to play some other tricks here, the square root of 2/4, which is the same as 1/2, minus root 3 over 4. See where I'm going here? I've got a common denominator. Can I keep moving? No, I can't. Okay. And then finally, I can factor out that 1/4. Square root 1/4 2 minus root 3. And I can take the square root of 1/4. That's just 1/2. So I finally get square root 2 minus root 3, all under the square root there, over 2. And that's pretty cool. So that's an interesting expression that is exact. You can put that in your calculator and get an approximate value of it, but it's an exact expression that is what sine of 15 degrees is equal to. So if we wanted to, we could expand our unit circle to include 15 degrees, and we could put that square root of 2 minus root 3 all over 2 in there. But we won't. But we could. But we won't. Okay. Got the idea? All right, let's try this again. So we're going to use now the cosine formula. We've got cosine of 165. Again, an angle that's not on our unit circle. But by rewriting that as the cosine of 330 over 2, so 330 is twice 165, so you're rewriting as cosine of 330 over 2, hint, hint, 330 degrees is on our unit circle. We now can rewrite this as plus or minus the square root of 1 plus cosine 330 degrees over 2. And moving forward, I do have to think about the plus or minus. So if I go back and look at my original expression that I'm trying to simplify or evaluate, 165 is in the second quadrant, which means that the cosine is going to be negative. So that means this plus or minus should just be negative. I want an answer that's going to be negative. So this becomes negative minus. Now cosine, well, it's 1 plus cosine of 330 degrees. That's on the unit circle. That's root 3 over 2 again. Square root goes over like that. And I got over 2. And at this point, you can see that the form of this answer is almost identical to the form of this one. So all of that, frankly, very cool algebra that goes on over here to get to that. We could replicate that in this case and get an answer that's in the same form as that. So let's cut to the chase and do that. This is going to be, come down here, equal to minus root, ugliest root, 2 plus root 3, all into that. So it's sort of like a square root within a square root, which is cool, all over 2. Again, a neat, compact, exact expression of what cosine of 165 degrees is equal to. All right. Lastly, cosine of b equals 4/5, and b is in the first quadrant. Find cosine of 2b. This looks like it might actually be an application of the double angle formula, because we've got a cosine of 2b here Well, let's just plunge blindly ahead. Cosine of 2b. I've got actually, if you remember from the last page, 3 different ways, 3 different identities for the double angle of cosine. There's cosine squared of a minus sine squared of a. There's 2 cosine squared of a, and there's 2 minus 1, and there's 1 minus 2 sine squared of a. Anyway, 2 out of those 3 different identities have sine in them. Now, if I know what cosine of b is equal to, and I know where b is, which quadrant it's in, I can, and this is nice, I can actually work out what the sine of b is. That's not too bad. However, if I use the double angle formula that's in terms of cosine, I don't need to do that work. I can just use the value of cosine of b, which is known to be 4/5. So let me write the version of the identity that's just in terms of cosines. And that's going to be cosine of 2b equals 2 cosine squared of b minus 1. Okay, I happen to know what cosine of b is equal to. Cosine of b is equal to 4/5. So this is just 2 times 4/5 squared minus 1, which is equal to, let's see, 4/5, well, whatever, 2 times 16/25 minus 1 equals 32/25 minus 1 equals 32 minus 25 over 25 equals 7/25. Sweet. You're walking down the street someday and somebody says, hey, what's the cosine of 2b if cosine of b is 4/5? And you're like, I've got this. All right. Sorry. Okay, that's the end of chapter 11.